Okay. Chapter 4, Section 4, System of Equations in 3 Variables. Now, this is where all your work previously begins to really pay off. If you're able to do things successfully in 2 variables, 3 variables, although it is several times more time-consuming, yeah, that's fair to say, it's really the same process. So we're going to work on that. Now, for those of you who have already printed out the slides that are provided, you're looking at these slides. That's going to be a good thing. For the rest of you, you might make a note right now that we've got, let's see, 1, 2, 3, 4, 5 slides we're working through. Okay? Let's talk about what happens with 3 variables. We've been dealing with 2 variables in the Cartesian plane. Well, now suppose this is on a piece of paper, and we take this piece of paper and we lay it down on the desk in front of us. And as we do it, we rotate it around a bit. So now here's your y-axis right here. Here's your y. And your x-axis is now actually kind of facing you, isn't it? It's facing you, sort of popping out of this 3-dimensional representation, and your y-axis is where you previously had your x-axis. We've added a 3rd axis, and now this one is coming directly up from the point of origin right here. We now have 3 dimensions, and to name a point anywhere in this space, so we've got 3-dimensional space. Up here we had a 2-dimensional plane, and we had an ordered pair. Now with 3 dimensions we have ordered triplets, x, y, and z. Please notice that it is the convention in mathematics when you put together a pair or triplets to put them in alphabetical order. If I were to take 3 planes, and we'll represent them with, let's see, we've got the 1 plane, which I am representing as green. So this is a 2-dimensional plane, and then I've got another one, which I'm representing with yellow, and another one, which I'm representing with pink. Each of these represents 1 plane. A system of 3 variable first order. First order means everything, x is to the first power, y is to the first power, and z is to the first power. So this is representing a system of 3 variable first order equations in a system of 3 planes. We know that 2 points define a line. We also remember from geometry that 3 points define a plane. We're going to go through an example here. It's the best way to learn it, isn't it? So I have, are these all first order equations? Yes. So I have 3 variable first order equations. I want to combine these equations to eliminate the second variable. First, I'm going to have to combine them to eliminate one variable. Then I'll go to the second. So just like I did, just like you did with two variable equations, you're going to now, with three variable equations, look and see where's our best opportunity to eliminate a variable. Now I usually go for something that has nice multiples, which doesn't seem to happen here, or the smallest coefficients. So you might choose something else, but I'm going to try eliminating y. So I'm going to combine two of these equations. I'm going to number them. It's going to help us out. So I'm going to have number 1, number 2, didn't mean to do that, number 2, and number 3. Perhaps the easiest ones to combine, I'll go with easy first. Easiest ones to combine would be number 1 and number 3. What I would do here on this first pass is multiply number 1 by 2. Okay, let me write that down in a different color. So number 1, I'm going to multiply it by 2, which will give me 6x plus 4y minus 8z equals 2. I'm going to take the third equation and just write it as it is. 2x minus 4y plus 3z equals 17. So this setup was not that bad. I'm going to add these together, 8x. And this zeros, just as I wanted. I was trying to eliminate y. Add these together, I have minus 5z equal to 19. I'm going to put that over here. This is a two-variable equation that I developed from my three-variable. So I've used this equation and I've used this equation. However, I haven't touched equation number 2. I can't get away with that. I do have to do something with equation number 2. Let's see, what do you think would be the best thing to do with it? I think I'll combine it with equation 1 and equation 2. I'll change my colors again. This time I'm going to have to multiply. Wow, that is hard to read. Okay, multiply equation number 1. So I'm going to multiply number 1 by 3 and number 2, first time I'm using it, by 2. I think that'll work out nicely. Let's try it for the first one. Multiplying everything here by 3, I get 9x plus 6y minus 12z equals 3. Did I do that right? Multiplying everything by 3. 12, 6, 9. Yep. Multiply number 2 by 2. That would give me 10x minus 6y. See, this is going to work, isn't it? To eliminate my y's. That's what we said we were going to do. I'm still working on that. It isn't done until I have used all three equations and eliminated y. What was I doing? I'm multiplying by 2. So that's going to be plus 14z And 28 times 2 would be 56. I'm going to add these together, and I get 19x, this will 0, plus 2z equals 59. So this one is going up here now. 19x plus 2z equals 59. I eliminated one variable. That's done. Step 1 completed. And notice I had used all of my equations. Combine these two equations to eliminate a second variable. Now you're in familiar territory, aren't you? The only question is, what's the easiest way to do this? I wish this were 9 and this were 18. That'd be so much better. Well, I don't see any way out of it. I'm going to have to multiply both of them by something, and I'll try eliminating z. That's what I'm going to go for. So this one I'm going to multiply by 2, okay? And this one I'm going to multiply by 5. Oh, I think this is going to work out so nicely. When I multiply this one, I get 16x minus 10z equals 4. Oh, not 40. Come on. 20 times 2 would be 40. I've got 19 times 2, so it's going to be 38. Now 5 times 19. 5 times 20 would be 100. This is 5 less, so 95. I hope I'm not making arithmetic errors. I'm not pulling over my calculator. Maybe I should have been. And then 5 times 59. Well, 5 times 60 would be 300. This would be 5 less. So I think I've got 295. You'll tell me back in class if I didn't do it right, won't you? All right, so this is going to 0, and I'm going to have, adding this together, we're getting big numbers here, aren't we? 111. Looks like 111. And we add these together, we get 13. And add 1. Oh, sweet. X is equal to 3. Oh, it was looking very horrifying to me there for a moment. Now I want to know, let me start putting my answer together. I've got 3, and I need x. I've got x. I need y and z. Let me go for z next because I've got it right here. I'm going to use this equation. That'll be 8 times 3 minus 5z equals 19. So I've got a negative 5z, which is equal to 19 minus 24, or 5. So my z is equal to negative 1. So I've got negative 1 here. Now I have to figure out y. And I'm going back here to find the equation I think will be the easiest for me to use. I'm going to go with this one. That looks easiest to me. So I'll have 3 times x, and then x is, our x, the point we're looking at is 3. So that's 9. 3 times x is 9. Plus 2y, and of course it's the y I'm looking for, minus 4 times z. 4 times z will give me a negative 4. If I subtract a negative 4, that's right, all of that is equal to 1. So I've got 2y plus 13 equals 1. I'm going to subtract 13 from both sides, and I'll have a negative 12. Did I do that right? So my y is -6. See, it basically follows the rules that you learned earlier with two variable. Now I'm going to check this against the answer. Let's see if I can do it. Oh, it's forgetting. -2. Well now I'm concerned. So I had said it would be a -6. So now I don't know if this is a typo or if I introduced something sloppy in here. You know, I'm very capable of introducing something sloppy. I really am. So it could happen. I am going to let you tell me. And I will very much appreciate that. Then I'll make whatever change I need to. How many equations must you have? Absolute minimum, I guess. Must you have to solve a system of two variables? If you have two unknowns, you need two equations. Is there always a unique solution to a system of equations? Well, we've already seen this, that one of the things that can happen when you have two linear equations is that you get that one unique that is the most common thing that happens. However, there are other things that can happen, aren't there? You could have two lines which are, let's make this little symbol on them. We remember this from geometry. Two lines which say they're parallel, and then we'll have 0. Here we have 1, here we have 0, and there's still one other thing that can happen. What is that? We have coincident lines. They actually lie right on top of each other, and then we have an infinite number of solutions. We have a solution, that's for sure, but it isn't unique. It's got many of them. So the key word here is always, and the answer is no. What is the graph of a linear equation in three variables? It's a plane. The graph of a linear equation in two variables is a line, and in three variables is a plane. If an ordered triplet makes 2 out of 3 equations true in a system of equations, is it a solution of the system? 2 out of 3. We didn't talk about that. But the answer is no. For it to be a solution of the system, it has to be true for all equations in that system. This makes sense, doesn't it? All right. Here's another one for us to work on. Oh, and I'm liking it too. We're going to call this one number 1, this one number 2, and this one number 3. We're going to figure out which one we want to eliminate first, and then we'll eliminate the second variable. So I think I'm going to try for eliminate. I don't know which one you would choose, but I think I'll try eliminating z. Let's go for it. All I have to do for that one is to multiply the third equation by -1. So what I'm going to do, number 2, I'm not going to change at all. Let's say I multiply it by 1. And number 3, I'm going to multiply that by a negative 1. And what I end up with is x plus 2y plus z equals 12. And then I'm going to multiply by a negative 1, so I get negative x, negative y, negative z, that's what I want, equals negative 8. I add those together. Oh, what a happy thing to happen. X also got eliminated. I love it. And I have a single y, a positive y. How sweet is this? I'm moving along much faster than I have any right to plan on. All right. So I have a y equals 4. How sweet. Oh, this allows me now to go back in here and redo things in such a way that I used only 2 of these. Let's see, which 2 did I already use? I used this one and this one. Well, I know I must use this one. So I'm going to write it out. I'll change color. X plus 3, oh, come on. Well, I won't write 3y because 3 times y is 12. I know that, right? So I'll write 12 plus 4z equals 19. Well, that's not a very nice way to write it. I should do this. X plus 4z, and I'm going to subtract 12 from both sides, equals 7. I'm going to do something similar, so I've done this one now. That's good. I choose one more to work with here. This one looks like a good candidate to me. Look how simple it is. Don't you love it? I know that y is equal to 4, so I'm going to subtract 4 from both sides. And my system of 2 equations with 2 variables is going to look like this. Subtracting 4 from both sides, I'm going to have 4 over here, and my y, which is 4, is taken care of, plus z. So here's my system. So beautiful. Well, I'm going to eliminate x. Eliminate x. And I'm going to do that by multiplying number, well, I forget the numbers now. We'll just say multiplying by what do you think? Just leave it as a 1, right? I actually don't have to multiply it by anything. And this one, I do have to multiply by negative 1. Now, of course, you don't have to do that if you are willing to subtract equations. You know me, I'm not willing to subtract equations. First one doesn't change. By the way, the fact that I don't like to subtract them doesn't mean that you can't. Of course you can. Maybe for you that is even a little easier, and you do. As long as it follows the rules, you do what is easiest for you. 0, 3z equals 3. I do like this. I do. So I've got a z of 1. And the only one I have to figure out now is x. And I'm going to use, again, the easiest looking equation. X plus 4, that's my y, plus 1 equals 8. So my x plus 5 equals 8. My x is 3. I hardly dare go back and look at the answer I have right here, but oh, it's a match. It's awful when you begin to think a match is a miracle. It should always match. The only reason it wouldn't would be an error has been made earlier. Well, 25 minutes in and we're done. You're going to give me some information back on this one. I look forward to it. See you in class.